Introduction. What is coupling? Couplings are mechanical elements that couples two drive elements which enable motion to be transferred from one element to another. The drive elements are normally shafts. We tend to see a lot of applications of the couplings mainly in the automobiles. For example, the drive shaft which connects the engine and the rear axle in a bus or any automobile is connected by means of a universal joint. The primary purpose of couplings is to join two pieces of rotating equipment while permitting some degree of misalignment or end movement or both. Be careful. Selection, installation and maintenance of couplings. Substantial savings can be made in reduced maintenance costs and downtime. There are various types of coupling based on area of application and misalignment or degree of freedom to move in any direction, such as the universal coupling allows the shaft to move in any direction. So this is the 3D diagram and the plan of ISO sheet of universal coupling. So the left side of the slide is about the assembling of universal coupling. Meanwhile, the right side of the part is about the plan of universal coupling. So this is the step to produce. Part 1, which is fork. Step 1. Choose the 2-point center rectangle and point it to the center of drawing. Step 2. Make the rectangle to 57 mm times 84 mm. Step 3. Finish the sketch and extrude it to 16 mm. Step 4. Select the blue area and create new sketch. Step 5. Make a line at the center to 34 mm and make two circles. The first circle is 40 mm and the second circle is 16 mm. Step 6. Make two lines at bottom end and hit the circle with the line. Do not forget to trim the circle inside. Step 9. Choose the blue area and create new sketch. Step 10. Make a circle at the center of the back and extrude it to 38 mm. Step 11. Choose the blue area and create new sketch. Step 12. Make a line on the center of the circle and choose mirror and mirror line to the center of the circle.
Step 13. Extrude the hole through all. Step 14. Fillet the area chosen to 3 mm and this part is complete. Save this part as fork. Step 2. Produce part 2, which is center. Step 1. Create a new sketch and make a circle about 32 mm and extrude it for 56 mm and make it symmetric. Step 2. Choose XY plane and create new sketch. Step 3. Go to view, choose white frame. After that, make a line in 18 mm and circle 32 mm at the end of the line. Step 4. Extrude the circle for 56 mm and make it symmetric. Step 5. Choose exact plane and create new sketch. Step 6. Make a circle at the center for 16 mm and extrude it. Make it symmetric and choose the bowline to cut. Step 7. Choose XY plane and create new sketch. Step 8. Make a circle at the center of the another circle for 16 mm and extrude it. Make it symmetric and the bowline is cut. Step 9. Go to view, then visual style and choose realistic to make it look real. Step 10. Fillet the selected for 3 mm and this part is complete. Save this part as center. Step to produce part 3, which is shaft. Step 1. Make a circle 30 mm and extrude it for 100 mm and make sure it extrude backward. Step 2. Select the blue area and create new sketch. Step 3. Draw a line and make square 8 mm times 7 mm at the upper center of the circle and finish sketch. Step 4. Extrude the square in 60 mm backward.
Step 5. Apply fillet the selected area for 3 mm. Step 6. Apply chamfer the selected area for 2 mm. This part is complete. Save this part as shaft. Step to produce part 4 which is bar key. For the step 1, make a rectangle 8mm multiply 7mm at the center and finish sketch. After that, extrude it to 56mm backward asymmetric. This part is complete. Save this part as a parallel key or bar key. Step to produce for part 5. For pin is step 1, make a circle 25mm, finish the sketch and extrude it 9mm downward. And step 2, select the blue area and create new sketch. Step 3, draw a circle 16mm at the center of the another circle and extrude it to 96mm. For the step 4, select XY plane and create new sketch. For step 5 is go to view, select visual style and choose wireframe. And then step 6 is draw a line 89mm from the bottom center and then draw a line both right and left. For the step 7 is draw a line upward 2mm at the end of the right side and make it parallel with the below line. The degree is 88.09. For the step 8 is revolve it and choose the boolean to cut. For the last step, the step 9 is go to view, select visual style and choose shaded with edge, and this part is complete. Save it as pin. Step to produce part 6, which is collar. For step 1 is draw two circle 25mm and 16mm at the center and extrude the outer circle for 10mm and make it asymmetric. And the step 2 is choose XY plane in origin and create new sketch.
Step 3 is go to view, select visual style and choose wireframe. Step 4, from the center, draw 15mm line on both right and left. For the right side, draw a line 2mm upward. For the left side, draw a line 1mm upward and continue draw the line and hit the 15mm lines end at the right side. The dimension of the dimension of the above plus below are 88.09. Step 5, revolve it and choose the boolean to cut. Step 6, go to view, select visual style and choose realistic to make it look real, and this part is complete. Save it as color. Step to produce part 7, which is taper pin. Step 1, from the center, draw a 15mm line for both right and left. For the right side, draw a 2mm line upward, and for the left side, draw a 1mm line upward. And from the end of 1mm line, continue to draw until the line hit at 2mm line upward at the right side and finish the sketch. Step 2, revolve the line that has been made. This part is complete. Save this part as taper pin. So, as you can see, this is the complete assembly of the universal coupling that has been made by us. So, this is the drawing of the universal coupling, which is sheet 1. This slide contains the 2D parts, and each part contains the dimension. As you can see, this is the drawing of universal coupling, which is sheet 2. This sheet contains part list and number of balloon for each component. So, the discussion. Mechanical couplings have a principal use in the connection of rotating shaft for the transfer of rotary motion and torque. As with all mechanical device, a coupling must match its intended purpose and application parameters, including many different performance, environmental, use and service factors. There are various reasons for which a coupling fails, such as improper installation, excessive vibration, abnormal noise and chattering, etc. The failure of coupling can be minimized by proper maintenance, such as checking and changing lubricant regularly, performing visual inspection, checking signs of wear and fatigue, and cleaning couplings regularly, etc. So, for the conclusion, mechanical design is a complex undertaking requiring many skills. Design and fabrication of a universal coupling was done in this project work. In designing problem, safe torque on shaft was determined. The cross pin size, which is diameter, was determined considering bearing stress, shearing stress and bending stress taken into account. The application of a universal coupling also studied in this project work. So, for the last slide, we would love to thanks to Madam Hanis Rashidah for teaching us this subject. Thank you, Madam.